All right, so in the last video, we figured out our formula that we're going to be using to deal with the time value of money, okay? And this formula is incredibly useful. And remember that at this point, we're talking about annual compounding interest. You don't even really know what that means yet. That'll be in the next video. But just keep that in mind. We're talking about annual compounding interest here. So let's think about this question, all right? And this is going to be a pretty easy video because you're really just plugging the values in, all right? I have $1,000 in a savings account earning 1.1% interest, which is pretty close to what a good interest rate would be right now in a savings account. How much money will I have in 12 years if I'm able to earn this rate? Okay. Well, we just need to plug the values in and make sure we're putting everything in the right place. The future value is going to be equal to $1,000 times 1 plus 0.11 times 12. That look okay? And I can tell you guys, when I'm grading quizzes and exams, I see these types of mistakes pretty frequently. See if you can take a second and figure out what I've done wrong here. Hopefully what you've recognized is this 0.11 is 11% interest, right? To turn something into a percent, you multiply the decimal into, multiply it by 100. So this would be an 11% growth rate. Pretty common to make these types of mistakes, and you just got to get real careful and practice a lot that you gain some confidence here so you don't make those types of mistakes. There we go. Now that's correct. 1.1% interest rate, okay? And all we got to do is just plug this in, and we'll see what we get. I've got my calculator. You should go through these and work alongside me to make sure that you're getting the same answers. So I'm just going to plug into my calculator and see what I get. And there we go. $1,140.29 is hopefully what you get. All right. You need to solve for this, and you also need to make sure that you can always interpret these answers. What I mean by that is, when an answer gets spit out in your calculator, you got to be the type of person that knows what that answer means. And I run into students who can solve, but they don't know what it means. And it's really a useless skill, right? If you can solve, but you don't know what you're doing, what the hell are you doing it for, right? It's not accomplishing anything. You need to understand what you're trying to accomplish. So in this case, what this would tell you is, if you save $1,000 in this savings account for 12 years, this is how much money you'll have after those 12 years are up, okay? That's all it tells you, right? It's a relatively simple thing to interpret, and as we get through some of these other questions, it'll start getting more challenging, making sure that you understand the number that you are solving for. All right, so that's relatively easy. We can do the same thing with debt. I'm going to be solving right alongside you guys because I'm hoping you get in the habit of doing just like me, having your calculator and solving. I'm just going to make up some questions as we go here. Let's say that I have $18,000 in credit card debt. How much will I owe? In 20 years, if I don't make any payments or anything, right? If I just let the credit card debt just grow, I don't contribute any debt, any additional debt, right? I don't use my credit card to make any more purchases, but I also don't make any payments, all right? And so this is kind of a useful thing because this will show how dangerous it is to have credit card debt. And interest rates on credit cards, usually really high, right? So let's assume that the interest rate here is 20%. Which is pretty close to an average credit card interest rate. So what I'm going to do is, again, just use my formula. I know my present value. That's how much I owe up front. I know my interest rate. And I know my number of years, which is 20. All right, so as long as I've set up everything correctly here, really a piece of cake, right? Hopefully you get the same answer as me. There we go. I'm just rounding to the nearest penny. to get this answer, $690,076.80, right? That's a lot of debt, right? You know, a lot of times people will talk about credit card debt as being something that can really financially destroy you, and they're not lying, right? Credit card debt is one of those things in the personal finance world. There's things that a lot of these gurus and so-called experts, they'll provide advice. It's not always very good advice, frankly. But one thing that you will pretty much always get is good advice about credit card debt. That advice is to almost always avoid it, right, at all costs, because the debt is just so tremendously devastating. In addition to debt growing very fast over time, holding this debt will essentially ruin your credit score, making it very hard to borrow money in the future. So you definitely want to avoid credit card debt. All right, well, let's shift gears here a little bit. I'm 34 years old, and this is a question that I realistically have for myself. I would like to retire at age 51. That's my goal. I got 17 years to go. All right. Currently, at this moment, when I'm teaching this video, I'm 34 years old. So I would like to retire at age 51 in 17 years. I need to have about $1.4 million to retire. If that sounds like a lot, keep in mind, the earlier you retire, the more money you're going to have, right? Because you got more time that you need to be able to spend it. And frankly, for a lot of people, that wouldn't be enough. I live kind of a cheap life, right? I live in Milledgeville. It's relatively low cost here, so that'd probably do it for me and my family. So I'd like to retire at age 51. I need to have $1.4 million to retire. I can expect to earn about 9% interest, let's say. Maybe investing mainly in stocks, I might expect to earn about 9% interest. So the question then is, based on all the variables that you have, right? In this question so far, what I have is the future value, which is how much I need in the future. I have my interest rate, and I have my N, 17 years. So you can see the unknown here is the present value. So the question is, if I didn't want to save any more money, how much would I need to have now, right? So how much would I need to save now to accomplish this goal if I'm not going to make any more contributions? It's kind of a nice exercise, right? Because I might think, how close am I to my goal if I think about it this way? At what point can I stop saving money if I'm trying to reach my goal? So now notice what I'm doing here is I'm going to rearrange this formula. This is the formula the way it's given to you here at the top of the board. But what I now need to do is solve for present value. And to solve for present value, what I'm going to do essentially is I'm going to divide both sides of the equation by the 1 plus I raised to the n, right? Cancels out here and allows me to isolate present value. Okay, hopefully that all makes sense. Again, all I did was I took this equation right here, I divided both sides by the 1 plus I raised to the n. In doing so, I effectively eliminate it on the right-hand side of the equation, and then I'm left with a solvable equation. So to rewrite that, the present value is equal to the future value divided by 1 plus I raised to the n. All right? These two are the same formulas. Some students like to try to memorize this. You can memorize it if you want. My feeling always is, though, I don't want to try to memorize a lot, because the problem with memorizing is if you forget it, you're kind of stuck, right? So I don't really even try to memorize it in my head. I just memorize this formula, right? And if I know this formula, I can do whatever I need to do with it. I'm not going to have to try to memorize anything else, right? I only need to know one formula here if I know how to simplify to solve for present value as I just did. So this is the formula I'm going to use. Let's now put in values. All right, the present value is equal to the future value, which is at 1.4 million, divided by 1 plus the interest rate raised to the n, raised to the 17 there. Okay? Just use your calculator to figure out what you get. Just make sure you're being very careful when you do your solving. It's kind of easy to make a mistake on these. Put an extra zero, leave off a zero, something like that. Pretty easy to do. So there we go. That's how much I would need to have if I'm going to stop saving any money, right? So if I had this amount of money right now, if I really was just trying to reach my goal, if I had that much money saved in the stock market, I might say, I don't really have to save anymore if I'm just focused on meeting my goal, right? So it's a pretty useful exercise. Now, what you probably recognize, those of you who understand things a little bit, is there's no guarantee about what the stock market is going to return, right? There's no way to know that for sure. There's probably no way to know if $1.4 million will be enough. I got to factor in things like inflation. These are all things we're going to talk about as we get through the class, right? But for now, this is a nice way just to estimate how much I need to have today. All right, so far we've solved for future value, good there. We've solved for present value, good there. There's two other variables here that we could solve for, and these are going to be a good bit more complicated. So let's see if we can do that now. So again, here is my starting place. I'm just going to rewrite this up here so I've got it. And let's think about trying to solve now for n. Mathematically solving for n is a good bit more challenging than what we've been doing so far. Got to do things that, I got to be honest, things that I hadn't done mathematically for a while before teaching personal finance. And it's the type of thing you don't do if you're just, solving for your taxes or something. You don't ever use natural logs, for example. And what we're going to have here is the necessity to use natural logs to solve for n. Don't freak out if you're not super mathematically minded. The natural logs are just a tool to get us where we need to go. It's not something you're going to need to do actively very often in this class. Okay, it's kind of just one thing you'll ever have to do with natural logs in this class. So if you remember how to do this, that's really all you need. So I'm just going to go ahead and show you how to do this. All right, rather than giving you the question first, let me show you the math behind this. I want to figure out how to solve for n. All right, that's our goal. That's not super easy because it is an exponent, and so perhaps this is something you haven't seen in quite a while, how to isolate an exponent to solve for it, okay? What you have to do is you have to take the natural log. I might give you guys some resources to refresh your memory about what a natural log is, but you can think of it this way. Natural logs are useful when you want to convert an exponent into a whole number, right? Or into a rational number, I guess we could say. So if we're trying to solve for n, what we're going to do first is we're going to divide by present value on both sides, just to make things a little bit easier for us. All right, all I did was divide by present value on both sides. It cancels out here on the right-hand side of the equation. And we divide by present value here. Of course, it sticks around, right? So this is what we have here, and we're trying to solve for n. What you've got to do is take the natural log from both sides of these equations. Okay, that's what you get. Anytime you take the natural log of an exponent, it becomes just a whole number, a rational number, right? I'm not a mathematician. I think that's what I want to call it. So you take the natural log of the exponent, it just comes out in front of this equation here, right? So you're left with the natural log of the future value divided by the present value is equal to n times the natural log of 1 plus I, all right? And now we've pretty much got it whooped, all right? All we've got to do is divide by this little concept right here, right? This natural log of 1 plus I. If we divide this from both sides of the equation, then it cancels out here, right? That all goes away, and you're left with n equals that, all right? That quotient, okay? So a little bit tedious, all right? You can memorize this if you want to, or you can do like I like to do and just remember how to do it, right? Again, I don't want to memorize a lot because I'm afraid I'll forget. So I'm not going to try to memorize this personally, all right? But I know I can solve for n if I just remember how to do those mathematical steps, okay? So just to be clear, Here's our formula that we need. There we go. And now we can solve for n. So let's think about it. When would solving for n be useful? N is the number of years of growth that you have. You know, it actually, when you think about it, it becomes pretty practical. It becomes something that absolutely is useful. So let me give you a useful application. Let's say that I have $140,000 in the stock market. I'm trying to use numbers that aren't too far off from reality, right? I'm 34, I've been earning money for a while. I've got some money saved up, and I know I want to reach that goal of about $1.4 million. So now the question is not, you know, how much money do I need to save? It's how many years do I need to reach my goal? So I need to have $1.4 million to retire. So how many years until I reach my goal? And in this question, we'll just assume the interest rate is 9%. Again, we're going to talk more about interest rates in the future in terms of what you can realistically expect. All right, so this to me is nice because it's thinking about if I didn't save any more money, how long would it take for me to get to where I need to be if I get kind of a typical interest rate earned in the stock market? So now I can just apply my formula, right? Getting to that formula was kind of a mess, but once you have it, it's pretty easy. You just got to make sure you don't make any mathematical mistakes. So I'm just going to plug in the values that I have. So n equals the natural log of that divided by the natural log of 1 plus 0.09. Right? Again, it is kind of messy, right? It's kind of an ugly equation that we have there. But each individual thing is easy. I just got to do some division, some adding, take the natural log, piece of cake, right? So this is just going to come out to 10. So this is the natural log of 10, which I'm just going to rewrite out here. This is a step I could obviously choose to skip. I could just kind of store the answers in my calculator if I wanted to. Somebody out there right now watching this video is just watching me do this. Don't do that. Get your calculator out and work through these. Pause the video. Make sure you get the right answer. If you just watch me, you're not getting enough out of this, okay? So make sure you're replicating my results. So this is obviously much easier when you have a good calculator because you can store your answers in there and everything. The answer that I get is about 26.72 years. All right? So if I don't save any more money, it's going to take me about 26, 27 years to reach my goal. Right? Which I like that. I like that. It's a nice way to accomplish something that seems relatively complex when you think about it. But given just this same formula that we've been having all along, you can do a lot with it, right? We've already seen that. You can solve for future value, present value, and now we see if it's solved for n. Any question like this you get on the quiz or exam is really just repetition. It's just doing the same type of stuff that we're doing right now. So it's not the easiest thing in the world. It's sometimes pretty tedious, but it's incredibly repetitive, which I think is convenient as a student because when you get to the quiz or the exam, you can sort of be prepared for the types of questions I'm going to ask. All right, so just one more thing here. By the way, let me make a quick note here. Sometimes I see students make this mistake. In fact, I would say out of all the mistakes that I see in this class, this is the most frequent error that students make is when they go to solve for something like this, they'll just do this, right? They'll round and then do some calculations. The problem is if you round and then give and solve for it that way, you're not always going to get the right answer. In fact, here, if I just take these values here and divide, I'm going to get 23.63, which is a good bit off from the answer that I get that's more the correct answer that I get here. If you're going to do rounding, don't round until you're done, right? This is a rule in math that I wish students would never mess up, because I see it so often. And a lot of times students don't understand why they're getting answers wrong. Here's the deal. When you're rounding, you got to be done. Whenever you're rounding something, you better be freaking done with your math. If you're rounding and then doing additional calculations, that's a problem. You're using estimates to solve for an answer. Don't do that. Use the real, actual, unestimated value to do your calculations. And then when you're done, then you can round. Okay? Here I'm reporting an answer, so it's okay for me to round. But I don't want to round and then do more math. Never do that in this class. All right, so for the final application of this formula, we need to solve for I, solving for the interest rate. And so kind of the same sort of deal. We need to figure out how to solve for that I correctly. So I'm going to take this formula and convert it into a formula that explicitly is solving for I. So essentially I've got to isolate that I, just like we did when we were solving for N. All right, so I'm just going to rewrite this formula a little bit bigger here. And let's think about what we can do. This exponent here is a bit of a problem, and that's where we're going to start. We're going to try to figure out how to get rid of that exponent. But first, let's kind of get the low-hanging fruit here. I want to move this present value over to the left-hand side. So I'm just going to divide both sides by present value. Okay. All right. And that's taking care of a little bit of our work, because it's essentially moved it to the left-hand side where it's out of the way of this I, right? I want to take, this is like, whenever you're doing math, it's kind of like you're playing basketball. You want to take the best player on the court, right? And isolate him, right? Put all the defenders away from him. So I'm trying to get this I here, and I'm trying to put all these other players on the left-hand side, right? This is Trae Young. I want to put all those other crappy Hawks on the left-hand side of the equation. So what I'm going to do that is I'm going to raise both sides of the equation to the 1 over n. All right, it's the nth root. It's kind of a weird thing, right? Normally when we think about something raised to the power, we think about it raised to a whole number, to the nth. Well, if you raise something to the nth power, right? If you raise something to the 10 to the 1 over n, for example, that's the same way you might write that, the nth root of 10, okay? It's kind of a weird mathematical concept, but we don't really care the purpose here. We don't really so much care about the math, because frankly, the calculator is going to do most of the work for us. We just got to make sure that we're setting everything up here correctly, all right? So I'm going to raise both sides of this equation to the 1 over n, all right? Left-hand side of the equation is going to hold on to that, raise to the 1 over n, all right? And when you take this and raise it to the 1 over n, effectively you cancel out the n, okay? And so this is now just 1 plus I. Now we've got it beat, right? Only thing left to do is subtract 1 from both sides of the equation. And so what you should get here is, this is ultimately what your solution looks like. There you go. That solves for I. There's your equation solving for I. Again, you can memorize that if you want to. That works. But of course, the problem is if you forget it, you're kind of screwed. So it's always easier to me to just to do the math rather than trying to memorize numbers. All right. So there's our formula for I. Okay. So now let's apply it. Okay, so let me try to come up with a question here. Another example. Let's say that I have $19,500 in a savings account, earning, let's say we're earning 3.9% interest. I'm sorry, that's not going to work. I don't want to give you the interest rate. So for example here, let's say that I'm trying to save money for a huge vacation, right? I've got this money set aside. I need $40,000 to do a world wide cruise. I'm going to cruise around the earth for 2 months. It's really expensive. It costs $40,000. And I'm trying to figure out what interest rate I need to get to accomplish this. I'd like to go in 15 years. I've got $19.5 thousand set aside in my savings account. I need to see if the interest rate is adequate. Okay? So what interest rate do I need to earn to accomplish this goal? Right? Solving for the interest rate. Useful. Maybe the least useful of all of these calculations, but still useful, still practical. I do this when I'm thinking about retirement. I've actually sat down and calculated, what sort of interest rate do I need based on how much I expect to save, right? It's really useful because I don't want to oversave. I don't want to save more money than I need to accomplish my goals. And I certainly don't want to undersave. So figuring out the interest rate is a nice way to sort of mitigate risk when I'm investing in a risky stock market. I need to sort of figure out what's reasonable to expect. So what interest rate do I need? All right. Here's my formula here. It's the one we just solved for. There we go. And I'm just going to plug and chug, right? Take the values that I have here, plug them into the equation. We'll see what we get. Here we go. So I'm just going to see what it comes out to. Hopefully you're doing the same. And what I get here for the interest rate is about 4.91%. So that is what I would need. Okay. So what I might do is look at the interest rate that I'm actually earning and see how that compares. Or maybe this money is in the stock market, and what I might do is I might look at some data and see over 15-year periods, how often does the interest rate average at least 4.9%? And I might figure out that 92% of the time I'm going to have enough money, right? So it's a nice way to think about how wealth accumulates over time, and there's many practical applications for it. Okay, you could do obviously the same thing with debt as well. So there we go, 4.91%. There's your answer, and now we've done all four. All four unknown variables in our equation here we can solve for. I'm giving you a bunch of practice problems that allow you to work through this. But don't make it harder than it is, okay? It's just one equation. We rewrote it so that we have 4 equations in total, but you're just plugging in values, all right? So if you practice this, you work through it sometimes, there's no reason why you can't do well on the quiz and exam.